So today I'm going to talk around cloud container security, primarily from a defensive standpoint. By that I mean not just about how we build it, but more about what do we do with some of that information, how does your SOC or your security engineers consume some of that information, and how do we ultimately avoid as much as possible things like alert overload and alert fatigue. So this might look familiar to some people. The initial one I did for B-Sides London on the Rookies track a few months back, Liz Rice dropped her second edition of Container Security literally 3 days before I did the talk. She coined this puzzle piece, not going to take her credit for it, but it's a really, really good baseline for helping people understand when we think of container security, there's lots of different pieces involved. So we think about, actually, there's the application security itself that we're building. We host it on something, whether that be cloud or own hardware. We've got the actual, whether it's Kubernetes, Docker, K3, some form of container runtime that we're looking at. And then we've also got our assurance friends. Let's not forget, they still play a part in all of this. They give us those requirements. And then we've got things like our runtime. So what's our application teams doing? Are they looking after our users? Are we running databases in there? What's happening with those? And quite often those are all separated across different teams within an organisation, especially really large FTSE companies. They will have 5 or 6 probably different independent teams working across different areas versus smaller teams, so small SME companies. They're really going to have a hard time with this because you get one person, say, doing all of your security and SOC, they're doing security engineering, they're hardening the cloud platform. So it's definitely a puzzle, and because it's so fragmented, because there's different teams, that creates a lot of human problem in there through no one's fault. Like, human behaviour is human behaviour. We all try to do the best we can when we're defending. But if I can't talk to what was just being said, if I can't pick up the phone when something goes wrong to query it with someone who actually knows the system inside out, that's really, really tough on the person that's picking up the phone to make that call. So, starting at the bottom, quick show of hands. Who understands what a kernel is?
Well, the first commercial one to the UK market.
That's good. This makes this a bit more fun. So, when we talk about container security, the very first thing people think of, especially in the application tier, I've been there, worked with them, I'm building my container, it sits in a pod, it's its own thing. It's happening, it's out there, it's completely isolated, no problem. But from a conceptual point, we take this building as the example. We're in a room, that's like a container. We're on a floor plate, which is a pod. But we're all using the same utilities. We've all got the same light source, power, electric. That's actually coming from the kernel. So whilst we think we're kind of isolated in this bit, actually it's all part of this bigger thing, and the kernel is the underlying bit that sits on top of the CPU that makes all of this work. So even though I'm giving this talk here, there's the red team one, there's the main auditorium speech going on at the same time. Actually, all of our recordings, I'm assuming, are all going into the same place, and someone can see those. So a few of the really interesting ones, just to give you an idea of how this comes into play. There was a RunC vulnerability last year. So this was a race condition. Called race because it's all about timing, it's exploiting a tiny little microsecond gap from when a container is initialized, that goes down to the kernel and comes back up. Someone doing something nefarious in the kernel, in the container, could raise that response back to the container to mount the host file system. So they're mounting the thing that the kernel sits on, so at the node level. Now, that lets them then break out to the node, which is then very bad because they can go, actually, I'm now just going to snoop on whatever the red team talking about right now. Second one, again, another type of breakout. There was, this year, SOC bypass. So the way this worked was when you're making calls to the Kubernetes API, that comes again, back down through the kernel, goes off to the Kubernetes API, comes back and comes across. The Kubernetes API can only look at so much, so it actually truncates the call. What they did with the SOC bypass was pad the call with over 1 megabyte of random blob. That was then evaluated. It goes, hey, nothing wrong with that. Comes back through the kernel. Actually, because the kernel's got the full thing, it's only handed off the truncated version of the Kubernetes API. It then executes on the whole payload. So that means Kubernetes thinks it's good. Actually, what we've sent to the kernel is something very malicious, and again, that lets you then break straight out into something else. So, whilst we like to think they're isolated, unfortunately, there is a bit of flaw in the system, which is we can break at the kernel level. Now, there are controls that you can put in place. There's various other bits you can do. So, using Linux namespaces, CNAMEs to restrict how much resource. So, I can't see all the electrics from all the other rooms. There are ways that we can help do this and help protect against this.
Is your specific view of containerization a Kubernetes style model? Because there are other ways of containerizing the system, but they have less dynamic capability. So you can actually make your kernel a VM, right? The kernel can be the VM.
True. And yes, and you can, again, it depends on your setup you're going with. Most of the time when I talk about this, it's because I'm creating it off public cloud, so AKS, EKS, GKS, public vendors.
So public cloud. Okay. So a bit clear.
It's also worth saying, if you're really, really worried about this type of thing and lateral movement, that might not be the right way to go. So, like you said, you can run it as your own cluster with its own node, having a dedicated workload. And actually you segment at both the workload level, you can segment at the VM level.
Yeah, you're just isolating the containerization from a security point of view is a little bit of a mirage.
A little bit.
And because you're going through the kernel level, you've got a priority escalation opportunity that can be exploited.
Yep.
That crosses over the containerization layers.
Yep.
Okay.
I won't get you to go and do this. You've got this. So, if we take a step back, let's think about it from a business, from a user standpoint. The user doesn't see the whole technology stack underneath. The user sees a web app or an interface somewhere. That has been built somehow by our good developer friends, software engineers, testers, you've got product people in there. How does this all get effectively from a whole load of code, bits and binary on one side, into a container on the other side that's then running? Well, typically, that goes to CI/CD. If you're being naughty, just use a Helm chart and deploy manually. You might just be writing in Notepad++. There's various ways to do it. What we start to then break down is this whole pipeline is a control face. So as I'm writing code, if I'm talking shift left, you can have plugins into your IDE. You can use AI in there, you can use all sorts of plugins to do dynamic SAST as you're writing your code, you can use things to help you maintain all your package files at the same time. Fundamentally, coming back, as you start to move through, the first major headache you get is around one open source. Pretty much everything we do now has some form of open source. Now, how many people heard of the Trivy hack that went on recently? So, for those that know, or don't know, sorry, Trivy got breached. Trivy is an infrastructure as code scanner. Does quite a bit more, but it identifies vulnerabilities in your code. It looks for credentials. It looks for secrets that are embedded in there. It looks at your cloud configurations to make sure you haven't misconfigured your cloud. Team PCP went and basically targeted Trivy as a piece of software supply chain. It's the most popular infrastructure as code scanner out there. I forget the exact stats, but it's staggering, and it gets even worse in a second. What they did was they rebuilt the Trivy binary itself, runs exactly as you'd expect, gives the results back. But on the back side of that, it's then scraping Gitpat tokens, so scraping all those credentials out of the system because they got hold of a developer's credentials, rebuilt it, that gets pushed up into the cloud. So there's a whole series of Trivy versions that are affected that then got deployed across basically everyone's estate. So anyone who's pulling the most recent version probably got hit. That's where it gets worse. That supply chain cascades. So they've used canister worm, they've been targeting team inside checkmarks. So checkmark got hit as a direct thing of Trivy. It's then hit Notebook LLM, Notebook Lite, get the right one. That has something like 83 million downloads. So we're not talking small things. And now they've now just hit Git Guardian, all from the same open source thing at the top. That is one example. Okay, that's a really catastrophic example, but it is a major problem with all of this open source. How do you secure it? Part of that comes into returnable repositories, but specifically for containers and trying to sort out all of this, actually you're looking at ephemeral hermetic runners. The idea being, even in the case of Trivy, this runner that builds the code happens in a sandbox with no internet connectivity at all. It can't talk out, it can't go anywhere. That means we can build it in isolation. We have some confidence that whatever's happening in that build is what it should be. Then go through all your standard things. I couldn't get a page big enough to put all the different things on, but some of the key bits around, are you doing your SAS test? Are you generating your SBOM? Are you generating your SAST and DAST and all your other security testing? Talking definitive. What do I do with that information? Well, most of the time, that sits with application. The application team are looking at that and fixing that, but that starts to be the very first signal that a SOC and defensive team can then use to actually go and harden their environments, lock them down, and actually use for provenance checking later on. So there's a really, really good thing you can do with your pipelines called attestation signing. So every event that runs in a pipeline generates an attestation. It says who it was that ran it, what it was that ran it. So was it a hermetic runner? Was it someone running it on an endpoint? What were the results? And gives it a nice cryptographic signature. That then you can send up into something like Record. So that's part of SigStore. There's some other tools out there. I'm a CNCF guy, so that's what I've said Record. That basically forms an immutable log of everything. So kind of similar to blockchain. Everything that happened to that individual piece of software, all the tests that ran, all the tests that passed, all the tests that failed, that all gets signed and stored in one place against this chart, so you can then go back and query it later. It gets even better, because you can then look at that using something like the OCI registry and slightly further down, VSA. So you're looking at the attestation that's provided to say, did it pass everything that it should have done? So verification, summary attestation, quite literally, did you pass my SBOM policy? Do you have critical vulnerabilities? Do you have all these other things? And then based on your individual environments, you can start to say, yep, you can deploy there, or no, you can't deploy there. So critically thinking of how do you harden this up from a security point for your production environments. If it has passed all the policies, just no go, you can't deploy. Versus if I'm deploying it to develop a sandbox, yeah, fine, you can deploy there, it might look slightly weird, but go ahead. That's also the record, and the way it can be used at that core nexus point is one of the key bits that we can use for the Security Ops Center. How does this play out in practice? We've got our lovely friends on AppSec doing the good things. They're generating SBOMs, they're following all the standards and guidance we give them. On the left-hand side, we've then got our SOC. They're coming in, probably alert fatigued. How does that play out? Well, actually, the very first thing they need isn't all the security results and all the scan results that are coming in from, have you done your SAST, what's in it, what are all the critical vulnerabilities. The more simple question is, did we build it? Did we sign it? Did it pass all of the things we expected it to be signed? Rather than necessarily trying to interrogate everything on the hood at the very start. So start really, really simple. Then how do we actually make use of that? Well, because of the way it works, so Record will give you a provenance chain, it gives you the SHA, it gives you all of that core information. We can join on with things like CMDB. We can enrich it automatically, by having to do it manually. Pull in your CMD, pull in your change logs. This thing has happened at this time on this asset. Well, we know what the asset is, but do we know the context of it? Is it business critical? Is it a back-end system? Is it, so the last talk, is it a print server that's running? Because that will then start to dictate how quickly and how often we react to something. And one of the key bits, I say this having worked a lot on the AppSec side, is it actually a schedule change? So a lot of the time, we can be doing what we think is a schedule change, and we've not told the SOC for whatever reason. Changes go through your ITSM for a reason, through your change management system. From a SOC perspective, if you don't have that, you're always going to be fighting what looks like something bad is happening, and quite often it's actually, yes, we're doing something, or we're going through a change, it's gone wrong, we're having to log in and do things manually to a database. It becomes one of the most critical pieces. So, going back to the point a bit earlier, I'm going to talk public cloud. This can apply, the same principles do apply to physical infrastructure, whether you be running it on something like running a Raspberry Pi at home, public cloud, private cloud, physical tin. What are some of those guardrails and sensors that start to feed into the SOC? So obviously we've talked about there is a container, it's built. Now, where's it run? Where does it sit? What's it actually run on? And what are some of the key concerns that SOC should be looking at? First one being identity. I think pretty much like most other people have said, identity is pretty much key to everything. Nothing should run without verified identity in an ideal world. Zero trust being the hypothetical utopia that we'd all love to push towards. That's difficult, it's complicated, it requires a lot of context. Where do we want to know? Well, what are things like the service accounts using? What is happening with my identity accounts? So is someone logging in to AWS from a random geographic location? Or are they logging in to get a secret to do a deployment that they've never used before and haven't used in the last 30 days? Those are the types of things that we can pull out and start to feed into the SOC. Now, caveat with identity, that's quite small in terms of log size, but we can go a step further. What about organisational policies, controls, and guardrails? Things like CloudTrail, CloudWatch, all that event logging at the actual management plane is a huge amount of volume. So we're probably not going to ingest all of that to a SOC, but having it there for threat hunters to be able to use, having it there if you have the incident is helpful. As always, it comes down to money cost though. How much can you afford to actually create and generate, and how much can you afford to store? With things like this, encryption being absolutely key. If we're running everything encrypted, we want to know who's signed what, who's using which keys. Those are the types of things we want to turn on. CSPM, again, it's an overlay that then lets us see into that world, but it costs a lot of money to run. Where a lot of the public cloud providers actually have a good thing for us is things like GuardDuty, Defender, that security aggregation layer. We don't need to integrate all of that information into the SIEM and SOC. You can use it at the cloud layer to help protect that, and then stream certain events from there into your SIEM or into a data lake. If you need to hold for regulatory requirements, different things, so say you want to know what your security posture is, you've got something like ISO 27001, you want to know on any given day, actually, have I got my audit of my identity and is it properly managed? You can stick that into a blob storage. So where's this now layer on top of? Well, if this is the foundational bit, everything uses identity, everything uses encryption, everything uses firewalls. On top of that sits our Kubernetes. I'm using Kubernetes as this example. And again, we go back to everything is sat on top of that one singular point. So underneath all of this, even if you're running on AWS or EKS, in the majority of cases, that's going to be a singular VM. Again, depending on how you segment it up, that can limit and change the exposure and blast radius. One of the scary points is, according to CCF, something like 80% of different companies aren't using any form of network protection internally. So I build my Kubernetes cluster, I build a cluster, that's sat out there on the internet, I've got my NAT firewall, I've got my internet gateway that sits there and protects the edge, but internally, pod to pod, container to container, even into different workflows, generally isn't protected and locked down. And that means if someone does get inside, they don't get a bit of a field day into, they can query across, they can go all over the place. And that's where things like service mesh start to come in. So it allows you to sidecar all of your containers to say, this specific container with this ID and this signature should be talking to this one over here. it allows you to start putting in granular rules that you can flex and say, actually, I want to tie everything into this database apart from this API. And it has to have this signature and this authorization to come and do that. So it's a way of being able to start breaking out everything that's happening, what's happening, at what time, put in network layer in the same way that we would have done traditionally in our data centers years ago, and still work with next-gen firewalls. We're just applying it at the micro level, effectively to the network interface attached to each one of these containers. The second one here is admission gates. So using admission gates and policy controllers, so admission controllers, actually stops a lot of really bad stuff happening. So going back to you build the container, you sign it, using policy code, whether that be at the infrastructure layer or at the deployment layer, to say, if you don't have a valid signature, you're not being deployed. That works really well for blocking known bad things coming in, but you can also flip it on its head. If I know that something bad is inside a container and that is spreading, and I know what that container is and that signature, I can flip the actual admission gate to say, tear all these things down in real time. I'm not saying that's a good thing or right thing to do in terms of instant response, but it gives you another tool in your arsenal if you are playing whack-a-mole with someone and you do need to get them out. So going across, we talked a lot about the higher level things, but actually what happens at container runtime? What's happening with the container itself? Now, the best will in the world, we can all build secure applications, we deploy them out there. There's a lot of open source attacks going on right now. It would not surprise me if that skyrockets again. So last year it was about 800% increase, according to Verizon. Hesitant to think if that's going to be that number again. If we're talking about how the application runs and where it goes to at the kernel level, what we start to look for is something like eBPF, so Enhanced Berkeley Packet Filtering. This is probably one of the most fine-grained but also noisy employment logs you can get. But it will tell you everything that is happening with the container. So the example I use is something like Nginx. Nginx, typical proxy, reverse proxy, sits out there internet facing. There has been numerous issues with it over years. Previously, I think it was about 4 years ago, they made a version that absolutely had to be run as root. That makes this even more interesting. What we can start to look at is Nginx is running normally. It suddenly makes a random syscall that we don't expect. So it's calling down to the Linux kernel and going, hey, I want to open a shell. Why is Nginx opening a shell? But that's logged at the kernel level. So it happens whether you look for it or not. The kernel is always going to register that and always handle that. Next thing it does, Nginx is doing curl. Depending on your telemetry and what you've got, hopefully most people would see a random curl to a random domain on their egress firewall. But firewalls are really busy and gnarly, and there's lots of information in there. Whereas what eBPF does, it goes, this process, which is Nginx, spun up a new one, and now it's trying to do another thing to do a curl, and now it's trying to do something after it's done the curl, and it starts to build that into a hierarchy. So everything is joined on. What it means from a security ops side is either we can start looking at this in real time, so there are tools out there like Tetragon, Falco, various others that use eBPF to say, actually I don't want it to do those rules, so block it, and the most advanced ones can block it based on behavior, what's known bad and known good. You can put rules in there to say, actually this front-end web server should never do anything like reaching out to some of the other areas. So it gives you really, really fine-grained, this is what's happening. But again, since some of the other talks going on, it's too much just to pump that into your sieve and SOC and just go, you know what, have at it. It would A, cost you a fortune, and B, you need to understand the Linux, you need to understand the process tree, you need to understand the natural behavior of what is normal for a container. So that's where the idea of defense graphs come in. I use the word defense graphs because it's a data problem. We've got lots of different tools, hence the defense bit. And GraphQL kind of influenced my thoughts on this. when we're talking about data, a lot of people, probably show of hands, who's heard of a data fabric or data mesh? Good news. The idea being, I'm working as a data engineer, I can start querying something from one place, and I can see it, even though the data is residing in somewhere else. That's the same type of logic we need to start taking from a defense side. A slight caveat with that is all the different tools speak slightly different languages. They all format things slightly different. So that's where something like open telemetry in the middle comes in. It standardizes what everything's called, it normalizes it to the same naming conventions, to the same formats, it helps baseline everything into the same way. So what we can do is we can take all of our EVPF events, we take things like our Kubernetes logs and audit logs. So those by default are turned off in AWS and EKS because they're so noisy, but we don't want to ingest them to the scene, so we can turn them on, stick them straight to S3, stick that into Glacier. We can then use a collector to use OpenTelemetry to then help query out those different bits we need. And then we're going to pump the most important stuff, so not the actual raw logs, not the events. We're going to use some intelligence on top of that, so correlation engines, we take a pick, there's a lot of them, there's lots of different ones you can use. But you're taking the data from multiple of these points on the left. So has something happened at the kernel level? So has eBPF gone, it's trying to spawn a shell. I've then seen a Kubernetes, an API call that's going to STS in AWS to get an identity and a service token, and then I've seen a weird network thing in the flow log. If yes, that's probably an alert we then push to the scene. But you're not pushing the raw logs around, you're trying to keep it as compact as possible. And it's about trying to pick off and layer off the different ones at different times, because otherwise we'd all become overwhelmed. Also from an application side, we can start taking those application WAF logs, the type of edge logs that we get, that can also feed into this. Most application teams are handling that. They'll have API monitoring, they'll have database monitoring. We take some of that information and actually enrich what we get from the SOC and C. How does this play out when you're actually doing it on the ground? It's difficult. Like, containers by their nature, cloud by its nature, is becoming more ephemeral. I hesitant to say more ephemeral, but even now we're seeing more a shift to tools like Fargate, where it's completely serverless-based approach. We aren't having persistence there. It makes some of this really, really difficult for actually going and investigating and then doing the cleanup. When you first get that alert in, Gartner's saying now, probably by 2028, 50% of what's done by a line 1 SOC analyst will be done by AI. Now, that's a scary thought for two reasons. One, you're giving AI a look at all your core information. What I've just talked about, eBPF is, these are the process IDs of everything running. Your CMDB tells it exactly what are your most critical assets. You've then got all of your application telemetry. Now, depending on how one of the other talks are saying, if you've misconfigured your URLs and you're locking all the tokens in the URLs, it then can see all of those. So there's a lot of consideration with that. The second one is, actually, a lot of people start in line 1 in the SOC. That's how they learn, that's how they develop as security analysts, and they mature into our threat hunters of tomorrow. And if they're not necessarily getting into the weeds of how does this work, they just take it from the AI, we might be starting to lose some of our critical thinking skills that we really need. So, level 1 is more around the data enrichment. Do we have the right data to understand what's going on? Like I said before, do we have our CMDB things? Do we understand the criticality? Do we understand where this is and what's happening? Is it in our public cloud or is it in our on-prem? Is that public cloud connected to the internet or is it behind a firewall that's locked off 57 layers deep with bunkers? Then line 2 becomes more around what's happening at the process level. What's the container doing? What is that process doing, the function doing? How do we pick that apart and start to work out, is this normal behavior for that specific thing, or is this something new and novel? Is it someone's exploiting a 0-day and trying to do something? Is it they're trying to do remote code execution? Then tier 3 is more looking at the impactful things. So revoking credentials, like revoking a service account, whilst it helps lock things down, that can completely stop a different department from working. If they're looking at certificates and rotating certificates, doing certificate revocation, again, that can knock entire systems and even enterprises offline if you think about certificate pinning from an external next-gen firewall inspection point of view. So they're really focusing on those hard points. And then we also get into things like, what happens with how are we going to do forensics? For layers 1 and 2, forensics is probably almost out of the question, just because by its nature, a container might be there for 5 minutes or less. You have to make a decision, are we actually going to keep the container and then we preserve some of its information, or do we kill it because it's doing active data expel? That is a complex decision that no one individual should be making on their own. That needs to be 2 people consulted to make that decision, not least because of legal ramifications, for preserving and tampering of evidence. Defence lawyers love it. Having seen that, been through that, if you go and touch something, even a container, to preserve the evidence, you do it in the wrong way, you've just contaminated it. So that's also where having that secondary log aggregator with things like all your eBPF logs really helps, because even if you do make a mistake, you've still got a secondary load of evidence there. Now, there are tools out there to help you do containerized forensics. So you've got Checkpoint Restore that does basically at the container level, freezes it, puts it in time suspended, but again, you've frozen it. You could put a network rule around it so that actually it can't connect, it's just frozen in time, what's happening inside still happens, but it can't talk out, it can't do anything, it's now isolated even from the node itself. And similarly, actually, these are all running on a VM or a node somewhere. We need to go and think about forensics on the node as well, which in the cloud responsibility model is quite challenging, to be honest, because unless you're hosting it yourself, Amazon don't like you exactly going and imaging their own disks. If you're running self-hosted, that's great. You can go image the memory of that VM, you can image the disk rack, etc. Then how's this kind of wrapped together? Kind of filling the loop on assurance. So unfortunately, probably most of us are going to work in some form of regulated environment. We all want to be compliant with something like ISO, as painful as that might be. You might be handling a payment card, you might be working in a bank, you might be working something that's regulated third party, critical third parties. All of these different regulations things form requirements on the right. They're your baseline for what controls you're going to do, how are you going to do them, which ones do you need. So specifically things like identity. Every single team talks about identity, every team talks about backup. Make sure you understand those and plan those in from day one. Then we get into the controls. Your requirements from the foundation, scale out with your controls, build them into the different layers. Always assume that you are going to breach. The assume breach mentality works inside the SOC, but also works from a security architecture perspective. My personal favourite one is testing. Most of the time we talk about testing of controls or for doing a compliance exercises, we go and do it once a year. So even DORA now, it says you need to go and do exercise, test your controls, test your backups once a year. But most teams are deploying more than once a year. Cloud is evolving in real time. Your users are interacting, their expectations evolve in real time. There's tools out there now like Trusted Red Team, Gremlin, Lippers, Chaos. You can take what we've done from an SRE standpoint and now do it from a security angle. What that means is I have my process code, I've got my cloud controls, which I say are all aligned to DORA and IS2, whichever framework you're going to talk through. Actually, you can now start to harness the automated testing to start saying, is that control working as it should be? And probably an even more fun one, so previous talk mentioned around tabletop exercises, you can go a step further. Some teams and some companies use things called game days. They're not telling their application teams, the blue teams, the red teams, what's going to happen, but there is a plan, we're going to inject a fault into a critical system, and we're going to see how it works. We're going to see how people react when they don't know it's a tabletop, when they don't know this is coming. They won't know the scenarios, but it's been signed off at leadership. Probably your head of SOC would know, your head of application, if it's in the application side, your head of cloud. And the idea is, it's a learning event. yes, it's there to test, and yes, it's there to make sure that we meet with requirements and regulations. But now we can go and inject things and see, did the process break down? Was there a human fault? Because actually all the pressure got put on the level 1 analyst who just suddenly got overwhelmed with information. It helps us actually impact and really work on that human error so that it doesn't happen in real time, because when you do get a phone call in the night, it's really hard, A, to wake yourself up, and B, it can take you a few minutes to get going, think through everything, even logging on. So it's a really good way to actually make it more human, and from the higher up in the exec side, make them sit through it. They're signing this off, they're the ones saying let's go and fault inject. Make them sit through and see what those analysts are seeing, what the application engineer on call is seeing when they suddenly get a phone call. Let them see in the room as the water room's filling out, who's in there, who's saying what's the feeling of those teams in the room. Because quite often, in a lot of cases, our execs and leadership, they can be quite distant and peered off because they've got other things they're doing. But it's that time to bring the human element back into the room. So where does that leave us in terms of there's an awful lot you can do? Well, first thing, think about enforcing and mandating trust. Certain configurations within your container, so don't run as root, limit the different namespaces that you're using, use limitless namespaces. Use things like hermetic runners, or look to moving to hermetic runners which don't have access to the internet, and if possible, look at things like verification, summary, attestation. There's a specific framework for that called SOC. I always get it wrong, supply chain levels for software artifacts. They give a really good framework of scoring from 1 to 4. Have a look at that and see where you are on there versus where you kind of want to be, which is ideally level 3. And start thinking about how you can make sure that some of these basic fundamentals are in place, because if you do let people run as roots, you give them access to the kernel or the overlay file system, it will get abused, unfortunately. Think around what you're doing with your containment, and by that, are you using any form of network segregation internally on your clusters? Can my different pods talk to each other? Should they be talking to each other? How do I get a view into that world? So that could be using something like Cilium, Hubble. It could be you just go through the standard Kubernetes, right? So you can do Kubernetes namespace, you can do it then through Kubernetes networking. But have a think about how you divide those up to try and start limiting that blast radius. So when something does go wrong, because it will go wrong unfortunately, you've got something there to fall back on. Deploying visibility, in an ideal world, we'd have all the logs from everything and we could all understand them. Start small and slowly scale. So the idea of going straight to eBPF is quite scary. There's some really good books out there from Liz Rice, who does a lot of container. Kelsey Hightower has been talking about this recently. Look at things like Falco. Look at things like Tetragon. They're open source. You can use them, play around with them. They will give you an idea of what's happening at that kernel level, at that network interface level, to say, this is what my container's doing, is this normal? Don't feel rushed to get there though. Don't feel that's going to be the crown jewel, because getting the basics and the hygiene right actually helps solve a lot of this. The eBPF is kind of like the added gold mine that you need afterwards. And the final one is detect and respond. Have you got policies, code rules deployed? Do you know how to respond if one of those fires? Do you have any networking, any control rules fired, logged and stored? Do your analysts at level 1, level 2, level 3 know how they're going to respond? Do you know actually how you're going to do forensics? And what legal may say or may not say? And what the time period and notification is across different things like DORA, GDPR, UK DPIA? They're similar, but they're all different. So again, from an analyst side, the last thing you want to do is panic about that on the very last minute. That's all. Thank you very much.
I've got a few questions. I'll just start with one and try and keep it simple. As a runtime security model or securitization model, what you're looking at is a large amount of sensory data. But the obtaining of that sensory data seems to me to be highly dependent upon your ability to understand the behaviour or expected behaviour of your application. So it's hard to sort of define this, but that feels to me like a lot of work to get. I mean, I'm sure there's some things you can kind of automate, and sort of say just put these kind of rules in, they'll all work for everything, but to properly understand the expected behaviour of an application and then bring that into a runtime debug perspective and perception feels to me like a significant amount of effort. So is it, and how do you minimise it?
It's difficult. It's a lot of information, as you said. I try to think of it back through the layers. So the clouds at the hyperscale level, even hypervisors to a degree, have this kind of solved. So the idea of Defender can aggregate all the information that's happening across AWS. Same with Security Hub in AWS. It can aggregate a lot of that. It applies a lot of machine learning behind the scenes to try and flag what's wrong, what's abnormal. That comes pre-built in.
Okay.
Applications have been doing this for a while. So they've been using APMs, application performance monitoring. Those are similarly rule-based, but that's been there as a very, very mature thing for a very long time. Definitely 10 years plus. Where we're starting to now, to your point, probe that is the behaviour of a container isn't a question we've asked, really. Especially if we then start to get into things like Fargate and completely serverless. Tools out there like Falco, Tetragon, not going to reel them all off. They do have some level of intelligence built in. So they have default rules, they have default things, but it is still very rules-based. So similar to a next-gen firewall, there's only so much intelligence you can put into that machine before you have to program it yourself. That's where the crux is. That's where the security engineering, the real complex digging is. A SOC analyst doesn't have time to program that. Let's be really fair. SOC analysts are massively overloaded. Everyone I've talked to is pretty much burnt
Well,
out.
it doesn't feel like they should be doing it anyway. It feels like it should be an application side support.
Yeah. They shouldn't be because of separation of duty. So security, someone in the SOC shouldn't be going writing code to change your control framework. Whether that's DLP, your EDRs, pretty much any security tool, you're looking at someone on the other side of the fence because otherwise you have who watches the watchman. But you're right, that's a security engineering, probably a specialist person. It's not necessarily an application engineer or software engineer because it's a different domain. And that is a skills gap. There's some really good tutorials out there. Kirsty Hightower's literally doing a deep dive into BPF because he's been learning it. Definitely go check that out. There's some really good introductions. So Isovalent, who Liz Rice looks for, kind of, she's written a book for them specifically on how to deploy eBPF. So it's a good starting point. But think of that as like, that's the end of the journey. Think about the basic fundamentals first. Do I have my cloud logs? Do I have things like Kubernetes audit logs? So they're disabled, again, incredibly noisy, but incredible amounts of data for people to understand. And think about how you can use those different information points within there, because you're not going to need all of it.
Other questions?
Yeah.
You said about network policies and default denying. I know some of the Kubernetes hackers in the UK and other parts of the Kubernetes SIG response community. Have you ever come across anybody that's deployed network policies? Because everything I get back talking to people is, yeah, it's a good idea. Everybody says to do it. Nobody does it in practice.
I hope. I'm going to be careful what I say here just because of my job. Yes and no. It is what should be done. So in a standard cloud model, at the cloud layer, that's absolutely how it works. Like if you log into AWS or anywhere, even your next-gen firewalls nowadays, the final rule in there is denial. So you have to actively go, actually, and allow everything above that.
Yeah,
But at the Kubernetes layer, You're right.
You spin up EKS and it's basically open by default, and that's the Kubernetes security model.
Because it's incredibly complicated. It goes back to network architecture. Do I know which pod is supposed to talk to which? How is that supposed to talk? Which port's protocols? It's right the way back down into the weeds. And I get it, it is really, really hard. Now, I've already people on both sides of the fence. Some teams that are using it, some are not. Some who only deploy it in certain bits. So for example, if I have a database and I want to protect the database and the crown jewels, let's build some walls around that, rather than trying to worry about all the application interfaces and all the other bits above it. Let's harden off certain bits. I won't solve the whole problem, but solve some of it. Similarly to service mesh, it's great. However, don't be...
Sidecar performance, overheads.
Oh, that's coming back.
Yep. There is an overheads running everything, right? Even Falco, even the UBPF. Anything that runs on top of a CPU has attacks. Everything has memory attacks. Be skeptical of someone who says, oh, we can just deploy the service mesh, it will learn all the routing and whether that's good or bad, and then you just implement the rules. They can do that. They're just taking the data, seeing what's there, and then saying, this is what your data is doing. Right now, you've got these connections go from point A to point B, this from point B to point C, this is the port, this is the protocol. You need to review it. You need to go back to Architecture 101. You can't deploy these things without thinking, actually, I've talked about TCP, UDP, IPv4 versus IPv6. Are you using IPv6? I could kill it. And again, you can't push these things out in live. It's going to be a slow sequential. I look at a rule, I propose a rule, comes into your threat hunting. I propose we're going to turn off these ports, these protocols from this point. Look at it, monitor it for 3 months. That's ideal because you get a huge amount of telemetry. It's very slow. You can monitor it for a few days and then start to close the gap. Starting to close the gap slowly and doing explicit denies, whilst it's not the explicit block all at the end, does help. So start to close that gap, make that window as narrow as possible as you feel comfortable as an organisation. And again, it's organisations' risk as to whether they say, we're going to use it or not going to use it. And the stat, I mean, if 80% of teams aren't using network segregation, that probably gives you a clue to where the wider community is at.
But just linked to that, because and building on that kind of overhead thing, somebody who's planning out how to deploy, one of the things I'll be looking at is, okay, I can put all of this in, but it's going to add processing requirements, it's going to add movement of data requirements, and it's going to add storage requirements. Is there any data out there that gives me a rough idea how much it's going to cost me for the guy who's paying Amazon or whoever I'm using, how much more I'm going to have to pay them each month to deploy let's say, a half-decent version of this? Is there anything out there that gives me a number, a percentage? If it's costing me 10 grand a month, is it going to cost me 15 grand a month post adding this functionality?
Not as far as I know. So typically, if I'm building this out,
so it's hard to justify as an internal organisation if you can't tell somebody
100%.
how much it's going to cost you.
and that's part of the problem with all of this. We've got sensor data out there. Even switching on things like Security Hub, it costs. Even if you're running it in your own data center, on your own hardware, you've already paid for it. You're still looking at CPU overheads, power draw, cooling. That's still a cost to the organisation. It's a very, very difficult argument for a CISO to make. Where you can kind of get into it a bit is around that central, we're going to switch on certain things. So
well, the reason I was just asking is because if it was 10% on average, it might go to 20. And given that the cost of this, of the server side, is relatively, it's 5% of my overall deployment costs, I'd go noise, don't care about it, move on. If it was a 3x, it might move from noise to something I give a damn about. Right? So that's kind of why I'm trying to get my head around where on the spectrum are we with respect to that financial overhead for the deployment of something like this.
for me, I end on this slightly heavy log side. Like, it'd always have slightly more logs there because we can go threat hunting with them, because you can fall back on them for legal if you need to. Heaven forbid you do need to fall back on it.
So a more heavily regulated customer would probably want more of this because they need more defensiveness. But if you're not regulated, but you just want to be safe and secure, you might find yourself at the other end of the spectrum.
Which is why I talk about the assurance side and regulations. So things like DORA, things like NIS, they talk about some of it, but they don't prescribe, thou shalt have this audit log, this access log, this one.
I mean, CNI, you should be doing something of this at some level if you're in CNI.
Let's go back to why did the cloud providers turn the Kubernetes logs off by default?
Because nobody wants to pay.
Nobody wants to pay, they're big, they're heavy, and heaven forbid you start logging what's happening on the API when it's talking to etcd. Like, that is just literally it will scroll the wall in a matter of milliseconds with the amount of stuff that's going through it on a standard enterprise, even a small, medium one.
Yeah, sometimes people don't want to be auditable.
And then you've got the processing factor on top of that. So again, it comes down to your assurance levels, your risk posture. Typically it's people outside of security ops, outside of the day-to-day running of this thing, although it's going to be your head of SOC and your CISO who picks up the bill in most cases.
Yeah.
So I've got a two-parted question. The first question is kind of unrelated, but with shadow AI and AI-related incidents, what kind of visibility do you think analysts would want? And the second question is, what does a typical workflow look like when there's a shadow AI-related incident?
Oh God. Shadow AI is a bit of a headache.
Yeah.
So let's start on the premise. Most companies give you a laptop. That laptop will have some form of EDR, XDR. It will have some form of proxy, so you'll be tunneled back to your internet or you use a cloud proxy. So by default, they can see what's on your laptop and they understand what you're connected to, even with DNS over HTTPS, it's like headache coming. Where most people are looking for it at the moment is actually, are you trying to install something? So side loading, on my own personal laptop, I have nothing. I write Intune and things on there just to mimic what goes on in the environment. If I've got Intune on there or some other form of mobile device management, that will tell me I'm now trying to install Cursor or code install. That helps, but it doesn't fix the problem of, actually I can just go to the web page. A lot of the web pages we're seeing, and a lot of the next-gen firewalls, a lot of the proxy controls we've got are literally just blocking on the URL subdomains. So even though I can say, I don't want to go to ChatGPT, how many organizations use Microsoft by default? How many use Google by default? So you can't block those domains because you fundamentally need to operate as a company. Where we end up getting back into is you're looking at things like your firewalls, so your firewall logs to say, actually they are trying to go to ChatGPT, we know that's an AI site, don't let it. What is, domain fronting, you can spin up a new domain in a matter of seconds, there's new AI services coming out every single day, so you're looking at inline blocking of that traffic to assess what that site is in real time. Secondary part is, actually I have access to Google because I use it. I may have access to Copilot. Now, what am I putting in there? And that comes back to being able to see what can you see on the clipboard. So what is being interacted with, what files being uploaded and dropped. I forgot who it was from the FBI. Put a load of documents into a public cloud provider. That should have been blocked by the laptop and the endpoint and the DLP control. Where that kind of triggers into the SOC is they'll see actually this person's trying to get there, but most of the time that block's going to come in as it's blocked it, cool, move on. The DLP control is only going to fire if it's hit a we've blocked it. To go and see, actually in the case of the FBI one, it allowed it, so we've registered this person has picked up these files from these locations and they've put it into this URL, i.e. they've gone and put it in public. That's a workflow more from the threat hunting side. So you're going through and looking at are we, or as your hypothesis, we use AI, we use, say, Google, or whichever one it is, I think someone's gone and done shadow AI. I think they've gone and uploaded something they shouldn't, and then you start looking through the logs. We're kind of playing catch up. Now, there are some controls and things you can do to get around that. So virtualized workspaces, where you, rather than it being on the edge user's laptop, that sits in a cloud or a container or somewhere, and that controls what goes on there. So you can use AI governance modules to control which AIs you've got, which frontier models you use. Difficult. There's some open source ones, but there's still expense to running them. You've then got to connect them to your end user device. They're not always that practical. Also, just it's easier for a developer to use their laptop. So, hope that answers the question.
It